Hello, everyone. Welcome. Good afternoon, good morning, good evening. My name is David Sandalo. I'm the inaugural fellow at the Center on Global Energy Policy at Columbia University and co-director of the Energy Environment Concentration, School of International Public Affairs there. And I'm delighted to welcome you to our event on food and climate change. So food systems contribute 21 to 37% of global greenhouse gas emissions, according to the best available estimate. That is, to state the obvious, a very significant percentage of the global total. But food systems have received far less attention than energy and transport systems in much of the global dialogue around climate change. And relatively little research has focused on the emissions impacts of the food system as a whole, from farm to transport, to processing, to packaging, to consumption, to disposal. That suggests there could be opportunities to significantly cut greenhouse gas emissions and improve the resilience of the food system with greater attention to these issues. Research is needed, especially to improve the data on these topics at the country level. And new policies focused on the food-climate connection could help significantly in meeting global climate goals. Many of these policies would also help improve public health, protect biodiversity, increase rural incomes, and enhance animal welfare. So to explore these issues, we've launched a food and climate project at the Center on Global Energy Policy in partnership with some extraordinary colleagues at the Columbia Earth Institute, New York University, and the Food and Agriculture Organization in Rome. And I'm delighted that those colleagues are with us here today to talk about these issues. Those colleagues are Cynthia Rosenzweig of Columbia, Matthew Hayek of NYU, and Francesco Tubiella of the FAO in Rome, each of whom I'm going to introduce in a moment. We also have a great team working on this that includes a number of scholars, including Philip Benoit, Kevin Carl, Sally Chu, and others. And I'm especially thrilled that we're joined today by David Wallerstein, whose generous support is providing critical foundational funding for this project. Thank you, David. But before we get into presentations, we have some questions for you, the audience who have joined. We have hundreds of people who have joined here. And so if you could pull up the questions. Got about 60, or we'll do about 30 seconds to answer these questions. First, are you currently located in the New York metropolitan area, the United States, but not the New York metropolitan area, in a country other than the United States? And second, what best describes your areas of interest? And you can see this here. And we'll hold this open for another 20 seconds for people to answer. And this way we just get to know you and get to know each other and who's logged in here. All right, I think, why don't we take a look at the results? So we have, I'll read it out loud. We have 39% of people from the New York metropolitan area, 42% from the US out, and 20% from countries other than the United States. About half of our crowd considers themselves to be mainly interested in climate and energy, about 25% agriculture, 8% diets, and 15% other. Very interesting. Thank you all for joining us. We're really looking forward to this conversation. And let me just add that if we really hope to make this a dialogue. If you'd like to ask questions, you can do it with the question and answer buttons at the bottom of your Zoom screen, or you can do it by Twitter as well at Columbia U Energy. And we have people standing by to collect those questions. So with that, I'm really thrilled to introduce our first speaker, a tremendous colleague, Cynthia Rosenzweig. Cynthia is a senior research scientist at the NASA Goddard Institute for Space Studies, a professor at Barnard College, and a senior research scientist at the Earth Institute at Columbia. Dr. Rosenzweig is co-founder of the Agriculture Model Intercomparison and Improvement Project, known as AgMIP, and was the coordinating lead author of the food security chapter for the special report on climate change and land of the IPCC, the Intergovernmental Panel on Climate Change. Cynthia, welcome. Delighted you're here. And the floor is yours.
Thank you, David. Great to be here, and hello to everyone. going to share today how the Intergovernmental Panel on Climate Change expanded the focus of food and agriculture in the recent report on special report on climate change and land. If you look at all the literature, all the studies that have been done on climate change and food, I would estimate over 95% of those studies have focused on agriculture, on the production side, how climate change will affect crops and how crops affect. And the same with livestock and aquaculture and fisheries, really the production side of food. But what's happening now is that there is a real expansion in the focus beyond agricultural production, still absolutely fundamentally important, but realizing that in order to understand what's going on with climate change and food, we must bring in the processing of food, the value chains, getting the food from the farmers' fields to the tables, the role of markets and trade, as well as the table part, the demand side for food consumption and diet. Across all those three areas is the very significant issue of food loss and waste. And all of these elements now are considered in the food system. But at the same time, this food system approach takes us actually to warp scale, I would say, to planetary scale, because we are now seeing then, with this food system approach, we can then really work on how does the food system interact with the climate system? That's the focus of our project and our session today. How does it interact with the ecosystem side of the global systems? And of course, with people, the socioeconomics. So what does this focus on the food system get us? It really provides the potential for expanded goals. So not only, of course, first and fundamentally, we need food security for everyone on the planet, but we also then can begin to look at both human and planetary health at the same time. This food system feeds the great majority of world population, supports the livelihoods of over 1 billion people. However, it's not perfect, doesn't do a perfect job. There are still millions of people who are currently undernourished. And of course, on the other side, who are malnourished in regard to being overweight and obese. And just to let you know, there may be a quiz later on about some of the numbers. The food system contributes 21 to 37% of total anthropogenic greenhouse gas emissions, as David was just sharing. So looking at this in a little bit more depth, as we go to the food system approach to look at food systems emissions, the previous way agriculture emissions were measured, it's called AFLU, which stands for agriculture, forest, and other land uses, and does not take any emissions from pre and post production uses of energy into account. So when we add in the emissions, not just from agriculture and land use change, that's the agriculture and FOLU parts, but begin to look at and estimate and measure what about storage, transport, packaging, processing, retail, and consumption. That's how we get to this much higher estimate for the whole food system of 21 to 37% of anthropogenic greenhouse gas emissions. Now, of course, just finding out what the problems are is absolutely important, but the mitigation of these of the emissions is absolutely what we must do on regional and global scales. So there's been a lot of work on the supply side, on the production side, to contribute to climate change mitigation, reducing crop and livestock emissions, sequestering carbon in soils and biomass, and decreasing emissions intensity, being more efficient within sustainable production systems. So that's on the supply side. There's also been a lot of work on the supply side mitigation. But there's been now, as probably many of you are aware, there's been really now a growing focus on demand side mitigation and the role of diets. And what this chart is showing is the technical mitigation potential of changing diets by 2050. There's a range, of course, depending on dietary choices, but it's on the order of 3 to 8 gigatons of carbon equivalent per year. If those are, that's like what we call the technical mitigation potential. If everybody changed their diet, we know that that's, of course, a study heuristic, really. But we need to, when you look at costs of carbon, adding that into the equation, then the potentials are come down on the order of 2 to 3 gigatons of carbon equivalent per year. As we mentioned in the overview of the whole food system, the role of food loss and waste is absolutely critical. Defining the decrease in the quantity or quality of food as it goes through the production through to the consumption. An estimated 25 to 30% of all food produced is lost or wasted. This is enormous amounts of food loss and waste. And this is directly related to food security, because if we didn't have to be losing all that food, we could be feeding the undernourished. Of course, how to do that is always a challenge. And this can also support both climate change, not only mitigation, adaptation side, because there's going to be less, there would be less production that we would need to make resilient. But as always in all of this, the different contexts in different countries must be considered. One size does not fit all, and that is very important to always remember as we work in this very critical area. I'm going to share just 3 very quick findings also from the IPCC special report on climate change and land, because these 3 are key parts as we start our discussion focusing in on the food system emissions. The first is that climate change effects and impacts are already here on the food system. I think also you're probably all aware of this. The graphs are showing already in Europe with the warming temperatures since 1989, there has been actual decreases in yield trends of some of the crops. The one on the right is about food climate shocks, and the example of the 2010-2011 food price spike triggered by a heat wave in Eastern Europe. But this part of, it's no longer, of course, we all know this, climate change is not in the future anymore. It certainly is still in the future, but it is happening now. Another key part, very important to know about food, about the nutrition aspects, is that high CO2, which helps on the yield side and the production side, but it decreases the nutrient quality, in particular in protein, iron, and zinc. So as we are making the projections of how climate change will affect food, and taking not just the production side, but now the nutrition and the food quality side into account, this very important finding needs to be taken into account as well. Finally, don't forget adaptation. While we are working in reducing greenhouse gas emissions from the food system, we also have to be responding to those increasing climate extremes and shocks, and also the slower decadal type changes. And we have to work with farmers and smallholders all over the world, as well as large-scale commercial farmers to, again, all over the world, to develop adaptation packages, which can help to raise incomes and lower poverty rates in the face of climate change as the whole food system advances into the future. But it is pretty much shown that it's not always possible to compensate for the crop yield losses that climate change will bring. Our new research on food systems emissions, so this is what you're going to hear in the following talks, to create an integrated systems approach to design effective mitigation and adaptation strategies. we're creating country level. This is what you're going to hear about in the next talks. Create a country level database using the food system approach. Francesca is going to talk about that. Conducting policy analysis to help countries achieve effective food system mitigation, linking to the NDCs. David's going to talk about that. Matt's going to be really talking about this integrated systems approach that we use. And through it all, using social media to really communicate these absolutely key fundamental evidence base, the evidence base that comes from the research side, so that that we can all really and truly work on solving climate change together. If you want to know more about AgMIP, which David said, we're holding a virtual web shop on food systems shocks and actions. October 13th to 15th, we're going to have a special session, even more with really digging into the technical details of this project on October 12th. So please visit the AgMIP website and join if you'd like to learn more. Thank you very much. And David, back to you.
Cynthia, thank you for that tremendous presentation and for all your really pioneering work in this area. Before you go away, I have a quick follow-up question for you.
Oh, yes.
You know, we both spoke about this estimate of 21 to 37% of greenhouse gas emissions come from the food system, which when I read your Nature article, which talked about that a year or so ago, I was really struck by two things. First, what a large number that is, but second, what a big range it is. You know, I work some on energy systems, and you know, we have a much better sense of the contribution of individual fossil fuels, for example, to global warming than that range. We can define it more precisely. Why is it such a big range? What's the uncertainty attributable to?
Yes, well, I would say it's attributable to this new approach that we're taking now. See, there's been quite a bit of work done on some of the aspects of the food emissions. So for example, from livestock, methane emissions from livestock, those are reasonably well studied. But on the other hand, the food system emissions from the transport that really are only related to the food, or the energy on how people are cooking their food, and by the way, driving their cars to buy the food. These are the new elements that we're really addressing in our project to actually work on reducing that, to get a better handle on the numbers within that range, which I agree is pretty wide.
Great. All right. Well, thank you so much, Cynthia. We're going to come back after Matthew talks. So I'm delighted to introduce one of the co-leads on this project, Matthew Hayek, who is an assistant professor in the Department of Environmental Studies at New York University. Matthew received his PhD in environmental science and engineering from the Harvard John A. Paulson School of Engineering and Applied Science, and is just published one of many very interesting studies on this, and was in Nature, I think, or a leading journal. But before Matthew speaks, we have another poll, I believe. So Caitlin, if you could pull up poll, thank you. So we'll give people about 60 or 90 seconds to fill this in. I'll just read it aloud as you do. Which has higher emissions per pound, cheese or pork? Which tomato takes less energy to grow and ship to a market in New York City? One grown in a field in Colombia or one in a greenhouse in New York? And then what share of global emissions comes from the food system? These are Matthew's questions, so that's why we've got them up right now. All right, I think that's probably enough time. What answers do we have? Let's see. So let's see, 62% of our audience says that cheese has higher emissions per pound than 38 pork. 61% says that tomato grown in upstate New York. And 69% go with the 21 to 37% on question 3. Matthew, would you like to start by sharing the right answers? Or
yes, actually, we changed things up a little bit for me to give the right answers in a slide in one of the slides that I'm presenting in my presentation.
Ah,
What I can say for the last one is that the majority is correct and people were paying attention, and 69% of people aced the quiz. So that quiz question. But regarding the other food products, we're going to get that into a little bit more in my presentation, which I'm going to go ahead and put up on the screen now.
great.
On reducing emissions through diet and demand. So, as Cynthia mentioned, we're not just thinking about how to change production on farms to potentially be more sustainable, but thinking of entire food systems as integrated. And the way that we exert, different pressure on the markets and market signals to what producers are growing through our diets, demand, and the amount of food that we waste. So today I'm going to be talking about some of the biggest climate impacts from our food production and systems, as well as some of the most drastic ways that consumers can potentially reduce some of those impacts and emissions in the future. What I hope we can think a little bit more expansively of consumers as not just individuals who create demand for resource-intensive foods, but as the communities, corporations, and governments in which we all participate on a daily basis, and hopefully think about how we can use the power of those collective groups to demand better. So first, I'm going to talk about some of the most demanding foods in our food system and alternatives that use fewer resources. And second, I'm going to talk about eating more sustainably is not just a personal choice, but can serve as a springboard for more collective action, with New York City as kind of a test case, being that this is Climate Week New York City. The first place that I want to start is all the food we throw out and waste. I have a bit of a larger range here from some of the statistics than Cynthia had, but they agree in very large terms, in very large swaths. About a fifth to a third is waste of all of our food globally is wasted. This wasted fraction is very similar for both developed and developing countries. But for poorer developing countries, a lot of food is lost in the supply chain before it makes it to market due to underdeveloped infrastructure like unreliable refrigeration and poor climate controls and dry storage. But for richer developed countries like the United States, most of it is wasted by supermarkets, dining service providers, and everyday people at home from the refrigerator or stale food in the pantry. Food waste is such an issue that it was actually ranked by Project Drawdown, who lists the top 100 most effective solutions to global climate change, as the third most effective solution. This is not just in food systems, but as an effective solution across all economic sectors. What reducing food waste does is it ultimately puts less food in landfills to decompose into methane, a powerful greenhouse gas, and it means that we have to waste and produce fewer resources in order to produce food in the first place. But what surprised many from this list when it came out is that in a close fourth was eating more plant-rich diets with less meat and dairy. And that's because these are some of the most resource-demanding foods out there. And these foods also produce tons of manure that emits methane and nitrous oxide, and animals themselves, particularly ruminants like cows and sheep, have high emissions of methane from their belches. Plant forms of protein like beans, nuts, and seeds, by comparison, result in only a small fraction of these emissions. So something that I'd like to highlight and add to this list of some of the most effective solutions to climate change is that these two kind of top food system interventions are far more related than we actually think. And that's because not all food waste is created equal. Some food products, including a lot of animal source foods, require a disproportionate amount of resources to produce. So throwing away that food also means throwing away those resources. It takes about 44% of the world's edible food crops to feed and maintain the lives of the animals that we eat and whose products that we eat. And that's not including all of the additional grasses and pasture and forage resources, fish byproducts, and minerals that are mined in order to supplement and feed the diets of animals that we raise to produce food. So why are these products, generally speaking, more inefficient than plant-based or aquatic or other products? Well, it all comes down to metabolism. It takes energy just to keep animals alive before it even begins putting on weight. So many resources, in fact, that chickens take 9 calories of feed for every 1 calorie of meat they end up producing, with the remaining about 88% of the feed energy that gets lost to the environment as urine, feces, and body heat. This efficiency can be improved through better animal science as well as feeding animals wastes, but these wastes cannot make up a majority of that energy, and ultimately the kind of physics of food pyramids end up prevailing. One of the prices that we pay for the amount of meat that's currently being eaten in developed countries and by global society is that price is key to understanding agricultural's impacts all over the world. So when we think of soy, we often think of health foods like soy milk and tofu and tempeh, but in the Amazon, where massive deforestation occurs and is still occurring in order to plant monocultures of soy crops, soy is crushed to produce about 20% of its weight in terms of oil, with the remaining defatted soy and crushed soybeans almost entirely being used to feed animals. And much of that is actually exported out of the country to Europe and China to feed intensively raised chicken and pork. All of this goes to show that climate change is not always from dirty looking polluting industry like ships and trucks belching smog into the atmosphere, because greenhouse gases are invisible. And many of the emissions in the food chain aren't necessarily from fossil fuels. So going to this next slide that represents all emissions from the food system, and this is one global scale estimate, but it is one estimate. So over on the left here, we have all of the emissions from food system. It's about a quarter or 26% of all emissions. But do know, as Cynthia mentioned, there are actually a number of estimates for total food system emissions, and there's a number of uncertainty. So it goes below this and it goes above this. But this estimate estimated that about a quarter of our food system emissions come from food, if you look at the bar on the left. Going over to expand that on the right, industrial processes in the food system, which are the ones that predominantly burn fossil fuels, are on top here on blue. And they account for about 18% of total food system emissions, with only about 6% coming from transportation. Of course, there's a lot of variability across countries and food chains. By contrast, about 2/3 of the emission across the food system come directly from livestock and fish, crops to feed animals, and the land clearing that's needed in order to provide more room for crops that feed animals and for pastures for the animals themselves. This comes to about 16% of total emissions coming from animal agriculture, which fits very well with the most recent estimates confirmed by the latest United Nations estimate, the FAO estimate from 2018. Foods therefore differ widely in terms of their greenhouse gas emissions. So if we look at beef, we can see that a vast majority of its emissions are due to land clearing in green and emissions from farm activities like methane and from belches and manure in brown, with only a tiny fraction of their emissions, and I'm going to point to it with my cursor, all the way over here in red. Bananas, of course, going down here, have a much larger fraction of their emissions as transportation in red, because bananas in the US are typically transported via shipping containers and trucks coming all the way from Guatemala and Ecuador. But as you can see on this chart, a banana from South America still has about 80 times fewer emissions than beef. And it goes to show that eating a banana from Ecuador has about 80 times fewer emissions than a steak that one would eat from the Hudson Valley. And now we're finally getting to our quiz questions. So here is cheese, and here is pork. There was a pretty even split in terms of what you guessed here. Cheese ended up eking out pork as having the higher emissions. And the reason it has the higher emissions is because while both pigs and dairy cows produce a lot of manure and emissions, cows on top of the manure that they produce also belch lots of methane from fermenting hay and grass in their stomachs. It also takes a lot of milk to produce cheese, so you'll actually notice that milk is lower on the chart, but milk contains mostly water and some whey, which are discarded in the cheese-making process. So now let's get to our tomato question, which most of you got wrong. As much as I hesitate to say that word because there is variability. In large strokes, that question, the answer to that question comes out. So these are conventional tomatoes. And what you can see is conventional tomatoes do tend to have a larger impact than a lot of other forms of plant foods and produce. But tomatoes produced in greenhouses in climates that can get cold, when you integrate an average year round from New York to Canada, have about 4 to 10 times higher emissions than conventional tomatoes, even if you factor in the emissions that come from transporting them all the way here from Canada or Mexico, from California or Mexico. So I think what ultimately this figure goes to show is there's a lot of information on it, is that this study that looked at over 90 different food commodities and over 37,000 different food production systems and farms, what they found was that in terms of greenhouse gas emissions, as well as water use and water pollution, the way that things generally stacked is this. What you eat tends to be far more important than where it comes from, and even the best forms of animal protein still tend to emit more, generally speaking, than plant food sources. And I need to skip through all of this again. Okay, so with that in mind, what are some of the opportunities to lower carbon emissions? This is not going to be an expansive area, and David, I think, has a lot more to say about how we're thinking about and framing these issues on a national and global scale. But we're going to start locally at New York City, since it is New York City Climate Week. So first, I really want to start out kind of to dismiss any potential misconceptions that folks have about plant-forward and plant-rich foods. Eating more plant-based no longer means being relegated to the salad bar and the slimy beans that are sitting on it, or unseasoned cold tofu. The greater New York area has some of the best Indian and Chinese and Ethiopian and Levant Middle Eastern food ever, with a number of plant-forward or entirely plant-based options. New York City has tropical sundaes made out of purple sweet potatoes and served out of bowls of dragon fruit. French pastry that contains no butter or eggs. This is actually a picture that I shot, indistinguishable from the authentic French millefeuille, and spicy hand-pulled Chinese noodles from Chelsea Market. But we can go beyond thinking about consumers, as I mentioned in the beginning. We can go beyond thinking of consumers as individuals and more about the institutions that we participate in purchase food. So companies can track food purchases and supply chain waste. Cafeterias can even remove trays to let people carry plates one at a time, so that students or other diners aren't stacking multiple plates of food at once and throwing half of it out. And these are empirically proven solutions. There are dozens on the Refed website that I would recommend folks check out. I would add that we can also make plant protein options the most prominent and predominant menu items on catering spreads and on restaurant menus, because this actually causes people to eat less meat without even realizing that they're doing it. We don't need to be draconian to make smart changes. Governments also tend to buy a lot of food, and New York schools just last year started Meatless Mondays with an emphasis on replacing meat with plant protein options. Mayor de Blasio himself said that cutting back on meat a little will help improve a lot of New Yorkers' health and reduce greenhouse gas emissions. So specifically citing the benefits beyond, say, animal welfare or the health benefits to meeting climate goals. And this was extended in the One NYC 2050 New York City's Green New Deal, when they made commitments to reduce the city's red meat purchases, which tend to be some of the most resource exhaustive meats, by 50%, and phasing out the purchasing of all processed meat, which was classified 2 years ago by the World Health Organization as a type 1 carcinogen, for slightly increasing the risk of colorectal cancer. And lastly, I think changing our personal purchases and what our tax dollars buy through government action aren't the only ways that consumers and citizens can vote with their dollars, because we can also change what we in our institutions value investments in and divest from. Just as there's an ongoing movement to divest from fossil fuels and eliminating dirty, I think there can be more exploration of eliminating dirty food production from pensions and other important investments, as this is a majorly unexplored area of potential pressure. So this is really a very small sampling of all the creative solutions that are out there. And I've started with these solutions that are feasible for a city like New York, as well as your own workplaces and communities. And David, who is presenting next, has a lot more to say about how we can evaluate the efficacy of policies at a country or global scale. And I'd encourage everyone to think how we can make important changes in our personal lives, not just to feel better about ourselves, but because these changes can make change seem feasible on an institutional scale to lessen food waste and provide delicious, lower impact food. So with that, I thank you.
Matthew, thank you for that tremendous presentation. And really interesting. We're going to come back to some questions about it in the question and answer period. And actually now our next speaker is actually Francesco Tubiello, who I'm going to introduce. Francesco is the senior statistician and head of the Environmental Statistics Division at the Food and Agriculture Organization in Rome. He's contributed as a lead author to several IPCC reports on climate, food security, and agriculture. At FAO, Francesco leads data collection on satellite and on sustainable and productive agriculture, which is SDG 2.4.1. Francesco, thank you for joining us.
Thank you, David. Glad to be here. Let me share my screen. Please let me know when.
Yes, we can see it.
So,
can you turn it to full screen, maybe?
Yeah, I'm trying.
Yeah.
Here we go. Let me just get a pointer as well. All right. So what I will talk about in a bit changing, not the topic for sure, but sort of the angle of this event is I will be talking about the actual data, if you will, under the hood of all of this dialogue that we are been engaged in on food and agriculture and climate change over the last several years. Of course, I work in statistics at FAO, so we see statistics as providing the evidence base, not only for policy making, of course, but as a base for any practical action. You need to know basically what your problem is when you put your resources to solving it. But the work that I'm going to present focuses on advancing the current knowledge and the current data that we have. And this is what this project, David, that you mentioned with you guys, Columbia University and NYU, is focused on. So before I get into the details of data on food and agriculture and of importance to emissions, let me just, first of all, I have to warn you, I have very few slides, which is a good thing, but they're packed with information. So that's why I have a pointer here to try to make the presentation easy. So it all starts from an FAO perspective and from my work there with FAOstat. Many of you may have used data from FAOstat or heard about it. It's considered one of the largest databases and repositories on food and agriculture data. And in fact, provides information over a long time series for all countries in the world. In fact, it covers 200 between countries and independent territories. And I'm in charge of the collection of agri-environmental data. So let's say at the core of this data are input data, for example, on the use of fertilizers and pesticides and the description of how land is used for agricultural production. And this is an activity that actually takes a bulk of our resources over the year by sending questionnaires to our member countries and then receiving data, analyzing them, talking back to them if there's something we don't understand. And finally, we disseminate new information every year. This is sort of the core statistical work we're engaged in, but then we've moved one step forward in an attempt to serve our member countries in their need to report along a number of critical international processes. Of course, the one that is important here, the two ones that are important here are the climate change process. And David, you're going to talk more about the process and the NDCs and how the policy fits into that venue. But equally important, of course, is the 2030 Sustainable Agenda, where food and agriculture play a pivotal role in ensuring that poverty, especially in rural areas is reduced, minimized over the next 10 years. So what we do is we produce a number of synthetic domains that try to address and provide information to countries, especially to poorer countries that might not have the capacity to produce the data. And among these are a set of domains on agricultural emissions. So if you go in FAUSTAT and you look for agricultural emissions or land use emissions, you'll see a series of maps with data attached that you can download and play with to your heart's content. Now, these domains cover all of what we call the farm gate activities that generate emissions from agriculture. So we've heard from Cynthia and Matthew about the percentages and the importance of these emissions in the total that we emit from all sectors. One thing perhaps to also highlight is that the agriculture within the farm gate, that means crop and livestock production, is a major producer of non-CO2 gases, so methane and nitrous oxide. And actually, agriculture plays the lion's share of those emissions. If you think about that, the old methane that we emit from human activities into the atmosphere, 50% comes from agriculture. And actually 2/3, 75% of the N2O is N2O produced from agriculture. Now, we've spent the last almost decade in ensuring that FAO can provide to the world information on emissions from within the farm gate that are updated every year. And as David has mentioned and Matthew has mentioned, these are data that are then basically used by the community, the academic community, to move forward on a number of important analyses. But in a nutshell, these are the emissions that we have covered, so getting into this project, in a sense. So the emissions from livestock, which cover about 2/3 of all emissions from agriculture. And you can see here in these two graphs, and we will be sharing these presentations or sending them to those of you who might be interested. You see here the data that we collect and we disseminate by country and by year allow you for, let's say, a detailed analysis, like I said before, of the details, of what's under the hood of the global story. So on the one hand, you can see that in terms of the amount of livestock used globally, of course, cattle plays, again, a fundamental role. So sure, there are those processes that are emitting methane because of the enteric fermentation in particular, but there's also lots of them. And as you look at the typology of emissions by animal type, again, you see some of the things that then make it all the way into explaining why certain food commodities are more emitting than others. And again, the largest emissions from all animals are from cattle, whether it's beef or cattle. And then different typologies and contributions from other animals from different processes. Now, the first half of the story is the livestock and cropland emissions. These are mainly methane and N2O, as we said before. And these cover, if you look at them now in the aggregate, and we use CO2 equivalents to do that, they cover, roughly, just to have a number that's easy to remember, it's 10% of the total emissions that we produce every year in the atmosphere. Doesn't look like a huge number, except that we need to add to these emissions within the farm gate what we do to turn ecosystem land, natural ecosystems into production. We've done that in Europe and in the States many centuries ago, but there are parts of the world where that is going on right now and causes a lot of carbon losses and therefore carbon emissions into the atmosphere. Some of the processes that are depicted here are linked, for example, to the degradation of peatlands. These are natural organic soils rich with water that are typically drained to put cultivations for food. Southeast Asia, Indonesia, Malaysia, for example, are case in point in relation to the cultivation of oil palm and production of palm oil. And of course, some of this degradation comes with destruction by fire. So the two processes that are not typically associated to clean agricultural production pictures that you see on the left side here, actually major drivers of emissions. And you've got two examples of how we deal and quantify these emissions, looking, in this case, not at the statistics that come from countries, but at information from satellites, for example. This is a map of the drainage of peatlands in Indonesia and Malaysia. And these are graphs that depict, and I apologize for the small print, but they depict over time trends in deforestation, so carbon losses through deforestation over time from the 90s to current in various continents. And so you can start from the data to tell interesting stories. For example, in terms of deforestation, the large weight of deforestation, largely in Brazil, even today, but which has come down significantly over time, and the increasing role, even relative role, in terms of total global emissions that Africa is still playing as a continent. So this is sort of where FAO has developed its expertise and data production, in terms of offering a global knowledge product that it's available to everyone for use. And as Cynthia and Matthew have noted before, this is only part of the story. It's a very important part of the story because these emissions together already constitute, within the limitations and uncertainties that we've discussed and highlighted before, but about a quarter of all anthropogenic emissions. We already know today that maybe another 50% in addition comes from outside of these processes, from supply chains, etc. So before we get there, I just wanted to show you how those same emissions that I've discussed in the previous slides can be read in another lens. So this is a share of total emissions, so shares of the total emissions from agriculture and associated land use, which we see here in an orange bar, divided in their role from within the farm gate, that's the yellow, and the land use change in the green. What I wanted to show in this graph is something that my colleagues have already alluded to. So what is the value of these statistics? I mean, of course, they're useful to provide us with a bird's eye view on the global picture and the trends and where we are as a planet. But then, because they are granular and they provide information by country, in this case, you see them aggregated at the regional scale, they provide you with an understanding of how different these trends are in different parts of the world, which means also that the problem of food and agriculture and following up food systems at large will have, if not local, at least regional or nationally specific solutions. Just to give you an example here, you see that Africa is very different from Europe in the sense of, well, not only in terms of the contribution of agriculture and land use to the total emissions, which is very high, but from the fact that land use degradation is the main driver of these emissions. Whereas in Europe, what you see in North America is small relative share of emissions and a dominance of production within the farm gate. Now, I close just by pointing out to what we are working in these products in terms of moving the statistics forward. We already have mentioned what is important to account for, both emissions from industry, but also all the emissions along on the demand side and along the supply chains. And so the people that are involved in this project and those that David has mentioned and many others in our respective institutions are working actively as we speak in adding this data richness to FAUSTAT, so that those that are then interested in delineating the policy situations and highlighting solutions can use them as a base for decision making. So I'll just conclude by again reminding everyone and thanking, of course, my colleagues for their engagement. There is a new project that sees FAO collaborating with Columbia University and New York University. And the part that I am working and focusing on is the one that on the expansion of the existing database. The importance that we see, including at FAO, is that the information richness at country and regional level will allow for a detailed analysis of how mitigation options change, not only over time, but regionally. And stay tuned, because our plans are because we are full of energies, and as I said, we've started to work on this already for a few months now. We're expecting the first data to come out by next spring. So with that, I thank you, and I leave the floor to David.
Francesco, thank you so much. You are leading global authority on this, and the data that you manage, I think it's the best available data on these topics. So speaking for myself, I'm really delighted to be working together on these issues. The next, I'm going to give a presentation, and then we're going to turn to questions from the audience. We have some tremendous questions. A short presentation. And let's see if I can pull it up. And my presentation, as you can see, is on food systems and the NDCs. And I'm going to talk about three topics: the role of the NDCs in international climate policy, food system elements in current NDCs, and then opportunities to strengthen the NDCs. So let's see. About half of you answered that you mainly come from the energy and climate world, and I'm guessing that most of you know what a nationally determined contribution is. But for those who don't pay attention to climate policy, let me just take a minute and explain this. This is an acronym that you hear a lot if you spend time with professionals working in climate change. This is a nationally determined contribution is another name for a climate action plan, a national climate action plan that every country in the world submits, at least every country that's a member of the Paris Agreement. It's really, this process at the heart of the Paris Agreement. And in 2015, essentially every country in the world submitted their national climate action plans to the UN Framework Convention on Climate Change. They're to be updated on a regular basis, and the updates are due in the next year. And so essentially every country in the world is going to be updating its national climate action plan and submitting those plans to the UN Framework Convention by about a year from now, a little bit more. And to date, only 12 countries have done that, representing 3.6% of global greenhouse gas emissions. So around the world, national governments are going to be looking at their climate change strategies. Just one other background point here: the current NDCs, or the current climate action plans that have been submitted, are not adequate to limit warming to well below 2 degrees C or 3.6 degrees Fahrenheit, which is the goal that was adopted in the Paris Agreement. And this chart shows it. The blue line in this chart is what would happen if all the countries in the world followed the NDCs, and the green line is what we need to stay below 2 degrees C, or for those of you who grew up in the United States of America, 3.6 degrees F. And that's the global goal. And just one picture here: if the world warms 2 degrees C or 3.6 degrees F, this is what Miami looks like. And this is an image that was done by Climate Central out of Princeton. They have images like this for coastal cities all over the world. And as the climate experts on this in this meeting will know, the current estimate is that the world's not going to avoid this much warming. So we're in for some very serious impacts unless we can change course. So let me talk about the food system elements in the current NDCs. There was just an excellent study that was done by this that I highly commend to you. It was released by Climate Focus, excellent NGO out of Berlin, and WWF, UNEP, and EAT. And they looked at all of the NDCs that have been submitted, which are posted on a UN website, and looked at where the issues we're talking about today are mentioned. And here you can see the results. 90% of the NDCs mention agriculture, 50% mention livestock, and it goes all the way down, you can read the list yourself, to exactly 0% mention food waste, and 0% mention sustainable diets. So there's some real opportunities here to improve the response to climate change by considering these in national climate action plans in the year ahead. We've done some research at the Columbia Center on Global Energy Policy, especially want to thank Kevin Carl for this work, but we've looked at the, we did a word and linguistic analysis of the NDCs and looked for words within 7 words of the word food in all of the NDCs. What we found is by far the most popular word within 7 words of NDC is security or secure, and you can see a word cloud here that represents that. Agriculture, water, product come into, but this is what when countries submitted their NDCs 5 years ago and thought about food, they mainly thought about it in the context of security. We've been looking at opportunities to strengthen NDCs with food system measures. Our analysis on this is just starting, and we welcome thoughts and contributions on this topic. Let me just run through a few of them. And others are doing some very good work on this, of course. But one topic that's gotten a lot of attention is climate smart agriculture. And that includes efficient input use, soil carbon management, livestock management, ecosystem conservation, and other measures. A second is promoting energy efficiency throughout the food system. And that's including in transport, cooking, and cooling. There are really tremendous opportunities here. To reduce emissions from the food system by systematically improving energy efficiency. A third is reducing food waste. Matthew's already talked about this, but great opportunities here. Fourth is encouraging plant-rich diets that improve health while cutting greenhouse gas emissions. And Matthew's spoken about this also. There are policy measures such as nutritional guidelines, government procurement efforts that might be able to help in this regard. Labeling food products with life cycle greenhouse gas impacts could have an impact as well. There are consumers who care a lot about this. Nutritional labels have had an impact on diet. This is an area that's worth exploring. And then providing universal access to clean cooking technologies. Biomass cooking technologies and others that, and traditional cooking technologies are a major cause of disease in many places around the world. And they also cause greenhouse gas emissions, which could be addressed with universal access to clean cooking technologies. As part of our project, we're also developing a food systems policy map. This work is underway right now. Some great work by one of our associates, Julio de Barros, on this, along with the rest of our team. And we're developing a global map and feeding a number of different databases that provide information on agricultural emission policies, dietary guidelines, and food-related NDCs. And what we hope to do in the months ahead is to be able to launch this product so that anybody around the world who's interested in this can search on what individual countries are doing for examples and for support. And here we drill down, and this is, for example, this drilling down on Ecuador. And as you do that on our map, you'll be able to pull out individual examples of what individual countries are doing. One important measure, which we've only touched on, but I think is really important point when it comes to every issue we're talking about today, is that everything we're talking about in terms of potentially reducing emissions, greenhouse gas emissions related to the food system can have additional benefits for human health, for rural livelihoods, for biodiversity conservation, and for animal welfare. I work on a number of different public policy issues. I don't work on any that have the potential for this wide-ranging benefits across a really diverse set of issues. Thought we'd just end with this quote from the Eat Lancet report from 2019. Food is the single strongest lever to optimize human health and environmental sustainability on Earth. However, food is currently threatening both people and the planet. There's just huge opportunities to do better here. Thank you very much. Great. So with that, let me welcome. So thanks to the audience for listening. We really appreciate your time and attention here. And let me invite our the speakers back onto the screen. Hello, Francesco, and hello, Cynthia. So thank you, everybody, for your fantastic presentations. Really appreciate this. Let me raise this one general question. We haven't touched so far on COVID-19, which is obviously on everybody's mind in a number of different ways. It's shaping the dialogue on a number of different topics. Does any of you have any thoughts on kind of how the pandemic that we're all living through, that is what's gotten us on Zoom here, affects the issue that we're talking about? Cynthia, sure.
Yes, very much so. The two are just so strongly and intimately related. First, in a very overarching sense, both COVID and climate change impacts are global systemic risks that the world has to learn how to deal with. We're having, in an acute sense, dealing with it with COVID around the world now, and of course, climate change as well. That's what we as a human species have to learn how to do. Specifically about food connections, they're also highly intertwined across the whole food system. So first of all, I'll give just a few examples. On the production side, there are labor issues, farm labor, with people working, for example, in the meat packing plants, which then became hotspots of infection. That's just to give one example. There's also for farm labor for the people working in fields. On the transportation side, there have been boundary closings. There have been, and then in conjunction with the droughts and the heat waves, floods that we have in an increasing way through climate change. Those COVID and climate change interactions across the whole supply chains. And then finally, on the demand side, there are real nutrition aspects in terms of the food system and the increased vulnerability to COVID from the poor nutrition that I spoke about at the beginning of my talk, both on the undernutrition side and the overweight and obesity side, and the diabetes connections.
We have so many great questions from the crowd here. We're not going to be able to get to all of them. My apologies to people whose questions we're not able to get to. Let me just go to some of them. And Matthew, one of our participants asked about seasonality of food production. It said that you talked about kind of where the food comes from and how important that is in relation to what it is. Does it make a difference what season it's grown in?
Yes, I think marginally so. I think seasonality affects emissions insofar as they affect food transportation, right? I personally like and try to eat citrus from Florida only in the winter, as opposed to citrus in the summer when it comes from Argentina and South Africa. And, eating apples in the fall and berries in the middle of the summer. However, the cost of not doing so means that you have to transport those foods from farther away. So as we've seen, there's an opportunity to marginally affect food system emissions but it doesn't seem like as much of a lever for ramping down emissions than changing the profile of the diet to offset a significant amount of the fraction of meat or dairy that one eats with plant forms of protein.
Paula Schlussberg asks, are there any studies that look at differences, if any, between organic versus standard agriculture, between free-range animals versus CAFOs, concentrated animal feed operations, between small-scale family farms and large commercial farming? Anybody like to pick up on that?
Yeah, so I actually did a research project that I have a quick kind of supplemental slide that I could share.
Great.
So let me know if you can actually see this.
Yeah, we got it.
Okay, great. So we actually, a colleague of mine and I looked at the kind of potential opportunities for shifting away from fattening up cows in the final stage of their lives on corn and soy fed feedlots and moving them towards pasture. And we did some kind of population level modeling in order to understand what these consequences would be. And what we found is that if Americans didn't want to change, from eating about on average 60 pounds of beef a year, we would need 30% more cattle in the system, just because grass-finished cattle tend to fatten up more slowly and reach lower overall weights. So we would need to kill more animals just to produce the same amount. All of these additional animals and the more roughage feed that they're eating, where they're breaking down cellulose with bacteria and producing methane as a byproduct, would create more methane. It's a misconception that corn and soy fed animals belch more methane. In fact, grass-fed animals tend to. So this is something to be kind of cautious about. But I think the biggest trade-off that we're really talking about is that current pasture lands, if you're not supplementing with forage crops, and if you're not supplementing the end of their life with corn and soy, we already use about 30 to 35% of the entire land in the United States in order to produce beef, just for the beginning stages of their lives. If we wanted to move the end of their life to also be on pasture and produce all of this beef, we would need almost 4 times the amount of land. So essentially, we couldn't have a CAFO-free or a factory farm-free meat production system in the United States without also annexing Canada and Mexico. So it just goes to show, if we want to alter the way that we're producing meat on a large scale, dietary change and changing consumption really needs to be a part of the conversation.
Very interesting. Well, that's a good segue into a number of questions we had on that topic about the feasibility of changing diets. And we have some questions kind of skeptically posing the question, can you really induce people to change their diets? This is very culturally ingrained. People might have a negative reaction to being urged to do that. Any thoughts about that from Matthew or Cynthia, Francesco? You want to start, Matthew? I guess, or yeah, Cynthia, please.
So first of all, any discussion about dietary choices I believe needs to start with, perhaps not everyone has choices. So we just have to be extremely aware always about not being normative and saying everybody has to do this. That's why I said it's absolutely none of these things are cookie cutter. So that I feel is very important right from the get-go. The second thing is that in advanced economies, actually there are a lot of examples of people diets actually quite rapidly, or certainly concertedly. And so that there has been moves to consume less beef, not necessarily for climate change, but also for health reasons in some of the high developed countries. And there has been also significant development of the organic. Someone asked about the organic production methods. And there used to be, you had to search right in stores to find organic produce. And now you go like in, in the stores where I'm in the New York area also, there's just, much availability, much greater availability. Certainly, it's definitely possible for people to change. I would say, where there are choices available and where people can have almost, I would say, the luxury to be able to do that. I think we have to be very careful in terms of many contexts around the world, in developing countries, where these choices are just not as readily available, and that we have to be very, very cognizant of that.
If I may add, David, to this one,
Please.
As a segue, and of course supporting what Cynthia just said, in a sense, that's also part of the power of the data that we're putting together, right? In trying to assess, the different parts of the world or the different sections of societies where this is actually an issue and where it is not, right? Because looking at the data this way, in a sense, avoids looking at the problem in a generalistic way, right? I change diets across the board. In fact, the majority of people that live in the world probably eat a very low greenhouse gas diet, right? And it's largely a problem of well-off societies. So I would say identification of the problem with its own specificities, and then of course communication and education, right? If you think about it, over the last 20 years, a significant amount of people have stopped smoking, right? When it seemed an impossible thing, where through a combination of advertisement, communication, and sensitization on the health impacts of this. So it's doable. As long as it's understood that needs, the solution is through massive numbers of people adopting change, right? We can be the examples in certain adoption of behavior, but then if millions of people don't take up the example, then you don't mitigate the emission, right? Yeah. And sorry, on the COVID, I wanted to add a point because I was unable to unmute myself before.
Sure, absolutely.
Of course, you can imagine from an FAO perspective that this has been, huge focus of attention over the last several months, more from a perspective of impacts, right? Rather than mitigation, impacts on food production and food security, right? So COVID has disrupted markets across the economy, and of course has disrupted agricultural economies. Some of the repercussions being, livelihoods, but also waste of produce. So a decrease in supply to those that might need it the most. But again, everything, we spoke earlier in one of our presentations about linking back across the board, across the sustainability dimensions back to adaptation and food security, which links to the COVID, all of these themes.
Matthew, any final thoughts on this question? I know it's one you've thought about a lot.
Yeah. So the zooming back to talk about the question of choice and choices, not constraining choice in a kind of draconian way for people, I agree is going to be very important. And I love what Cynthia had to say about expanding choices before we start recommending which one is better for folks who may not even have to be able to make that choice in the first place. So I think expanding choices is very important, but where choices do exist, which is many places on Earth and most of the consumer dollars that are being spent on food and otherwise, changing the nature of that choice to where the default choice becomes the plant protein options, the plant options, the more sustainable options, the more sustainably sourced options, rather than the resource intensive meat products. Globally, whether countries are low income or high income, as they increase their income, and as countries and as individuals increase their income, they increase their meat consumption. But that is not a trend that is set in stone. That's just an observation. And there are a lot of important deviations from that. So Japan, for instance, has a much higher GDP than a lot of countries. And even compared to its countries that are just as rich or have just as much GDP as Japan, it consumes significantly less meat. There's a history of Shintoism, of Buddhism. There are certain kind of aspects of the food culture that just work to change what the default assumption about what a healthy or vibrant or sustaining diet is. And I think there's also, on that note of traditional diets, there's lots of room within traditional diets, and that most traditional diets on Earth, besides the very Arctic ones, have entirely rich histories of plant-rich, plant-predominant diets. So making sure that we're not kind of shipping this European-centric narrative that in order for a country to thrive, it needs to have more meat. In order for individuals to healthy, they need to have a slab of steak on their plate. I think if globally we can have a conversation about the co-benefits of eating less meat for those who have the choice, with things like health, with things like sustainability, and lastly, on the point that's been made now by Cynthia and Francesco on zoonotic disease risk. So I did want to talk about this one last kind of COVID-19 point, which is I don't think we're in the age of COVID-19. That would be like calling climate change the age of Katrina. It's climate change. We are now entering a era of increasing zoonotic disease risks. Why is that the case? So by zoonotic disease, I mean diseases that come from animals and interactions of animals, and then the hopping of those diseases over from animals to us. The United Nations Environmental Program cited 3 major risk factors for zoonotic disease emergence that we're talking about today. Deforestation, being predominantly driven by food commodities in the tropics. Intensification of animal agriculture, where you have hundreds to hundreds of thousands of the same species confined in sheds. And climate change, which food systems and other parts of the economy contribute to. All 3 of these are ratcheting up our probability that another COVID-19 pandemic is going to happen in the near future. And some of the best opportunities that we have of mitigating some of those harms are also mitigating climate change and making people healthier.
Such an important point. We have a number of technology-related questions and kind of R&D questions, some around plant-based meat and growing meat in a lab and other types of approaches to developing meat with new technologies. Does anybody have any thoughts or comments on that?
Sure, I'll start off. In the chapter, in the special report on climate change and land, and someone asked about insects too. So these are all covered there. So maybe we can put in the chat, we'll put in the chat box the link to the chapter on the IPCC. So, there's a lot of innovation going on, a lot of determined startups working on this, and first on the various types of technologies for alternative meat, basically. Some of them are cellular based, some of them are with other techniques. And what the chapter found, the chapter scientists found was in their assessment was that these are definitely worthy efforts, but they are still very, very, very early in any kind of real adoption and I would say like a real uptake. Yeah, now this doesn't mean that, as we were just saying, that there's definitely been changes in diets. So these are now, quote, really on the table. Same for insects. Again, very high in protein. Again, a whole another group of people are working on the insects as a potential meat substitute, protein providers. Again, there's the adoption issues, the whole going from the small scale to the larger, especially probably with the insects. There's a huge. There's also psychological studies. Some of the studies that we looked at. We're talking about changes of perception and how do you actually get, like for people to actually change their perception of some of these more really innovative types of food.
Great. We had a couple of questions actually on vertical farming, and that's the potential impact of that. Any thoughts?
I have some strong thoughts on this actually.
Okay.
So vertical farming's main play at reducing greenhouse gas emissions. I'm not talking about the water use now. I think that's a parallel question where we can have a lot of discussion, but its main kind of aim at improving sustainability from an emissions perspective is that food is going to be produced more locally. But as we've seen, transportations do not seem to be anywhere near the lion's share of emissions. And you have a much higher cost of blocking out the sun and having to produce that artificially through all or most of a vertical farm, such that greens right across the river from New Jersey can have a 10 to 20-fold higher impact than greens shipped all the way from California. However, there is a water savings play. However, on top of that, you can also save water just by producing a passive greenhouse or having kind of a glass or plastic tiled structure in which you're producing your lettuces or your greens that don't require that much sun. So I think these are, and this is nothing to say of things like tomatoes and wheat that require far more artificial sunlight to produce than the lettuces and baby kales that are currently being produced in these systems. So I don't just think it's that it happens to be inefficient right now. I think that there are basic principles of physics that prevent it from ever being as efficient as letting the sun power photosynthesis that can really never be overcome. However, I always hold these things softly and I always want to be proven wrong.
I'd like to hop in. One of the things about vertical farms is that a colleague at Columbia University, Dixon Despommier, is like the father of the vertical farms. He's had just cohorts of graduate students working on this, and I think Matthew, we need to be more encouraging about the innovation. Because then I was out at Berkeley with a class was taught by Michael Pollan, and and people, the students came up afterwards and said, "What about vertical farms? I want to be part of it." I think there are, so there's pluses and minuses with everything, but certainly reduce need for farmland if we're going to be having to do more on carbon sequestration. For example, the crop production, the yields are it's highly productive. It perhaps is immune to some of the weather disruptions. We don't know, but I think we have to think about that. The whole, with the conservation. And if they are truly developing closed cycles, then resource conservation as well. For example, can some of the nutrients be recycled? And for people in urban areas, this could be jobs, etc. So yes, there are profitability issues on very expensive land, right, in cities. The energy use has to be recycled, basically. It cannot be, if it's based on fossil fuels, forget it, basically. But if there can be the methane digesters, right, and developing the energy use from it, how to, and I think the water issues also, as Matthew's bringing up. But I just want to say, hey, we're going to need a lot, I think, I don't want to squash innovation by especially younger generation people who I think the idea is very appealing. So,
I would agree with that biggest point, that we don't want to rule any potential solutions out. And I think a lot of kind of papers come to this conclusion if we were to discuss the merits of organic agriculture, as an example, that buying organic actually results in higher land use and sometimes higher greenhouse gas emissions that come from fertilizer as opposed to animal manure, which tends to be used in organics. So there are actually major trade-offs with organics. But the thing is, when you buy an organic product or you invest in an organic company, you're not just paying for that product, you're paying for the research and development that finds ways to make that more efficient and more cyclical over time. So I think that in any of these applications, right, I've heard before that there are no silver bullets, we need a silver buckshot, or we need to kind of cast our net as widely as possible. And I would definitely agree with that. The types of things that Cynthia and I are talking about are the types of trade-offs that one should consider when they're starting a food business, when they're starting entrepreneurialism in the agricultural sector, because all of these trade-offs are very real with respect to one another. And with all of these, there are potentials for and ceilings to improvement.
Yeah, let me chip in on the vertical and the innovation, just to say, in terms of casting the wide net, and just put a perspective, since we're talking about climate change, on the one hand is the issue of reducing the footprint of the food that we produce. But increasingly over the next 30 to 40 years, with the population increasing, we know the mantra about that, right? We're going up to 10 billion people. Yields are plateauing and are expected to decrease in climate change scenarios that we are all familiar with. So in fact, solutions that work at increasing yields technically, right, to avoid, like Cynthia was saying, land expansion into areas that we want to preserve because of the carbon cycle, are most welcome. One of the solutions is vertical agriculture, and there are probably others. There are others. I mean, I just finished reading a book by an Italian plant neurobiologist, a visionary, who's talking about colonizing the ocean surface to gain on land use. So, yeah.
We are almost out of time. There's one topic that we haven't touched on, which is on aquaculture. Somebody asked about it. I just wonder we can at least quickly touch on that. Someone asked, how does the carbon intensity and sustainability of aquaponics closed system raising fish and plants synergistically compare with the same nutritional value and inputs for conventional agriculture and fishing? Any quick responses on that?
Well, I mean, some of this debate, so it's the same thing as the debate, the earlier questions on, plant-based versus livestock. I mean, some of these very issues are really issues between, traditional agriculture and intensive agriculture, right? Some of the solutions that we want to address, let's say, across the board are really solutions to minimize the negative effects of the intensive agriculture. So aquaculture with integrated with plant systems is part of a rich traditional agricultural systems that is clearly closer to a closed system that industrial production. And therefore I expect lower in greenhouse gas emissions, but overall more sustainable. Then there are issues, of course, of scale or the amount of food that is needed as an output that need to be all addressed. But just to note that, probably everyone attending knows, but aquaculture, fish production in aquaculture has surpassed fisheries catch, globally speaking. And, that speaks volumes to the need to, in terms of greenhouse gas emissions, it's still a very, very minor component, although important. But in terms of sustainability issues, this is of course coming to the fore very, very, very quickly as in need of being addressed.
Yeah, I wanna zoom back out on that the aquaculture issue, just to say that, I think these systems are getting aquaculture systems where we produce fish in a controlled way rather than going out to the ocean to catch them, are continuing to get more efficient, but I'm concerned that it's often not, that efficiency often isn't calculated correctly, in that often it's calculated in terms of how many pounds of feed it takes to produce pounds of fish. Yes, but feed tends to be dry and fish tend to have a lot of water in them. And something that often isn't accounted for is that the things that we feed to fish are often caught from the ocean. And that tends to put additional pressure on wild fish stocks sometimes for the very thing that we're trying to take pressure off of, we're trying to do in order to take pressure off of wild caught fish systems. So making sure that these aquaculture systems rely less on wild catch over time is very important, and to make sure we're accounting for something like the protein in the feed versus the protein in the fish, rather than just comparing weight to weight, so that we understand how efficient the nutrients are in order to produce in aquaculture systems, not just how many pounds of the product we're getting out there.
That's great. Well, the clock is wound down, and we're at the end of this session. I'm just going to end by returning to where we started. Emissions from the food system are 21 to 37% of global greenhouse gas emissions. That's a really big number. And that does not get the attention that it needs in the global response to climate change. We've launched a project with the leads that you've been seeing here today to develop better data on this topic and to develop policy responses. And we're really gratified the opportunity to engage with some of you, tell you what we're doing, and hear some of your great thoughts and questions. Apologies to the many people who offered thoughts and questions that we didn't get to, but we've got them all recorded and are going to include them as we go forward on this topic. And please reach out to us if you'd like to engage on these issues. I want to thank Cynthia Rosenzweig from Columbia University in Goddard, Francesco Tubiello from Food and Agriculture Institute, and Matthew Hayek from New York University. Also, David Wallerstein has provided generous funding for this project, and a team of really great researchers and colleagues who are working on this, as well as our fantastic team at the Center on Global Energy Policy, Caitlin Nicolina and others who have helped organize this event, as well as I think half a dozen other Climate Week events this week. So have a great rest of the day, everyone. Thank you for joining us. Look forward to the chance to connect in the future. Take care.
Thank you, everyone.
Thank you, David. Thank you, everybody.
Thank you.